Bismillahirrahmanirrahim. In today's lecture, we are going to study about functions. Definition of the function is that functions are special types of binary relations. It means that functions are basically binary relations satisfying some specific conditions. Okay, so it means that function is not a new concept, it is just a binary relation, but having some special feature makes it a different concept. Functions are special types of binary relations satisfying some specific conditions. So there are some specific condition, those binary relation which satisfy these condition. For example, number 1 and 2 we will be studying now. If the binary relation satisfies these two conditions, then they are called functions. Otherwise they will not be functions. Okay, I will explain this condition in detail. So functions are special types of binary relations satisfying some specific condition. As these are binary relations, it means they will be subset of some A cross B. Okay, so let F be a binary relation from A to B. Then you have a set A and a set B, a domain set, the set A from where we take the domain of the binary relation, and you have a set B from where we take the range of the binary relation. So if a binary relation is called a function, it is called a function if number 1, the first condition which a binary relation should satisfy to become a function is that the domain of F, okay, the domain of the binary relation F, if it is equal to A. Okay, if you find the domain of the binary relation that we have already studied in the previous lecture, we know how to find the domain of any binary relation. Okay, so if you are given a binary relation and they want to ask whether it is a function or not, what you are going to do is you are going to find the domain of that binary relation and you are going to compare it with its domain with the set A, because the domain may or may not be equal to set A. Okay, so if it is equal to set A, it means that this condition will be satisfies. This is the first condition of a binary relation to become a function. Okay, the first condition is that you are going to find the domain of the binary relation and you are going to compare it with the set A and just judge whether it is equal to set A or not. Okay, if it's equal to set A, it means this condition is satisfied. If it is not equal to set A, then it means that your binary relation will not be a function, because for a binary relation to become a function, it should satisfy both these conditions. Okay, if one of these fail, then the binary relation will never be a function. Okay, so these two conditions should be satisfied at the same time. Okay, so the first condition is that you are going to find the domain and compare it with A, whether it's equal to A or not. Second condition is that you are going to see if for every value of X we have a unique value of Y. Unique means one and only one. So you know that in a binary relation we have different ordered pairs. So for each first element of the ordered pair, you should have a unique value, one and only one value of Y, not more than one. Okay, in other words, in simple words, we can define this statement can be defined as, in other words, it can be defined as first element of the ordered pair should not repeat. Okay, so what you are going to see is that you are going to observe the binary relation which will be given to you, and you are going to observe whether the first element of the ordered pairs that are in the binary relations, whether the first element is repeated or not. If it's not repeated, then it means that it has a unique value of Y for it. Okay, we will understand better when we do an example. Let me take an example. For example, if we have set A equals to 1, 2 and 3, and you have another set B which is equal to A, B and C, and suppose that you have a function, suppose you have a binary relation F, and let it be 1 A, let it be 2 C, and 3, let us take A again, or it can be any, let let's take B for example. Okay, now let us check if this binary relation is a function or not. Okay, so the first thing that we are going to check is the first condition, whether the domain of this binary relation is equal to A or not. Now if I find the domain of this binary relation, what it will be equal to? Domain of F. We know that how we are going to get to the domain. We are going to collect the first element that are used in the ordered pairs, which will give us the domain. Okay, 1, 2, 3. These are the elements, the numbers which are used as the first element of the ordered pairs. Now this is the domain of this binary relation. Now the next step is to compare this domain of binary relation with the set A. Now if you compare both these sets, they are exactly equal. It means I can write that domain of the binary relation that we obtain is equal to the set A. So it means that first condition is satisfied. Okay, the first condition of the function is satisfied. Now I'm going to check the second condition. Okay, it will not become a function unless and until you get both the conditions satisfied. Okay, both conditions should satisfy at a time. Okay, it's compulsory. First condition is satisfied. Now to get to the second condition, for every value of x we have a unique value of y. Now if you observe this function, we know that for 1 we have only one value of y, that is A, and 1 is never used for any other ordered pairs as the first element. Okay, for 2 we have a unique value of C. We don't have any other value from here which is written as an ordered pair with the number 2. Okay, for 3 we have B only, not any other element from here. So it means that for each first element or for each x you have a unique value of y, or in other words you have non-repeating first element of the ordered pairs. 1 is over here and it is never repeated again. 2 is written just once, okay, and it's never repeated again in this binary relation. So it means that we have non-repeating first element. Okay, so in other words, first element of the ordered pair should not repeat. Okay, here the first element is not repeated. 1 is written only once, 2 is written only once, 3 is written only once. It is never used again in this binary relation. So it means that you have non-repeating first element of the ordered pairs. So it means that second condition is also satisfied. Okay, second condition is also satisfied, first condition is also satisfied. Both these conditions are satisfied by this binary relation, so this binary relation will be a function. Okay, so what do we conclude is that conclusion is that the given binary relation f is a function because it satisfied both the condition of a function. Okay, so this is how you check whether a given binary relation is a function or not. For it you will be given these two sets. Okay, and after writing these two sets you are going to write the binary relation which is given to you. Then you are going to compare the domain of this binary relation, whether it is equal to the set A or not. Okay, if it is equal to the set A, it means the first condition is satisfied. If it's not equal to set A, it means the first condition is not satisfied, and then you will clearly declare that this binary relation is not a function. You don't need to check the second condition then, because both these conditions should satisfy at the same time if your binary relation is a function. Okay, if one of these conditions satisfies and the other does not satisfy, then it will not be a function. Okay, you need both the condition to be satisfied for a binary relation to become a function. Okay, so the first condition, for the first condition you are going to check the domain of f. For the second condition you are going to check whether the first element is repeating or not. If it is non-repeating, okay, if it is non-repeating, then the condition is satisfied. If it was repeating, the condition would not have been satisfied. Okay, so then you are just going to write the conclusion that this is a function. Okay, if both the condition satisfies, if one of the condition fails, then you are going to say that this is not a function. Okay, so this is how you define a function. Let me do some more examples. Let me take another example. For example, you had let us take a to be equal to 1, 2, 3 and 4, and b to be equal to ab. Okay, and suppose that you have a binary relation g and it is equal to 1a, 2b and 3a. Okay, suppose you are given this and you want to check whether it is a binary relation or not, sorry, a function or not. Okay, so let us check whether this is a function or not. Now set a is 1, 2, 3, 4 and set b is ab. So let me check whether this g is a function or not. The first condition that we need to check is to find the domain of this binary relation. Now domain of g is equal to, if I find the domain of g, it is 1, 2 and 3. 1, 2 and 3. Okay, so the first condition is satisfied or not. The domain of g is 1, 2, 3. Okay, while the set a is 1, 2, 3, 4. Is it equal to set a or not? Of course not. Okay, this is not equal to set a. So the first condition for this binary relation to become a function is not satisfied. Okay, so you don't need to check the second condition, because even if the second condition satisfies, this binary relation will not be a function, because one of the condition has already failed to satisfy. Okay, so you are just going to declare that g is not a function because the first condition is not satisfied. G is not a function, and you don't need to check the second condition. Okay, because a binary relation is either function or it is not. There is no midway between these two. So the first condition is not satisfied, so you don't need to check the second condition, because for a binary relation to be a function, both these conditions should satisfy. Okay, if one of these conditions fail, then we say that the binary relation is not a function. So you don't need to check and go for the second, because we already know that it is not a function. Okay, let us take one more example. Now let me take one more example, and then we move to the types of function. This is example 3. Suppose a is equal to 1, 2 and 3, and b is the set a, b, c. Okay, and let us suppose that we are given a function g, a binary relation g. We are going to check whether it is a function or not, and let us suppose that it is equal to this. Okay, now let us check whether this is a function or not. Okay, first solution. First of all, we are going to check the first condition. Okay, let us check whether the domain of g is equal to a or not. If I calculate the domain of this binary relation, what is this? The domain will be 1, 2 and 3. Now if I compare it with A, both these sets are equal. So the domain of G is equal to A. So the first condition is satisfied. Now I will move to the second condition and check whether it is also satisfied or not. Okay, the first condition is satisfied. Now moving to the second condition, let me see if it has any repeating first element or not. Now for 1 there is a unique value of y, and that is A. Okay, for 2 there is not a unique value because 2 has two values of y, two corresponding values of y. Okay, 2 has the value b as y, also 2 has the value c as its y. So it means that 2 does not have a unique, does not have only one value of y. Okay, it has 2. B and C both are taken as the second element of this ordered pair. It means that this 2 is repeated, which is very clearly seen over here. Okay, 2 is repeating. So, and in the second condition we had said the first element of the ordered pair should not repeat. Okay, so here the first element is repeating, so we have repeating first element, which is against the second condition. Okay, which is opposite to the second condition that we want it to satisfy. So repeating first element, okay, we have a repeating first element, which implies that second condition is not satisfied. And so we have the conclusion. Conclusion is that G is not a function. Okay, not a function. Okay, so this is how you check whether a given binary relation is a function or not. We have done 3 examples. In the first example, both the conditions were satisfied. In the second example, the first condition was not satisfied. That's why we said that the given binary relation is not a function. Then we have done example 3, in which the first condition was satisfied but the second was not satisfied. Therefore we said that G is not a function because both the condition should get satisfied to make this binary relation a function. Okay, second condition did not satisfy. Both the conditions should satisfy to make this binary relation a function. And this is all for function. Now the next topic that I'm going to start is types of function. Now types of function, there are 3 types of functions. The first is the into function, onto function, and one function. Okay, there is a slight difference between these 3 functions according to the range of the binary relation. We will be observing the range of the binary relation to understand which type of function we have in our question. Okay, so they have all these 3 functions have their own definition, their own conditions. The first 2 conditions of the function that we have already done will be satisfied by all of them, because these are obviously function, and definitely for to become the type of function you need the binary relation to be a function first. So the first 2 conditions will be included in all these definition. Only there will be a third condition which will make the difference between these 3. Okay, so let me define them one by one. The first definition is of into function. Okay, the first type of function that we have is into function. Okay, it has 3 basic conditions. The first condition is that if you have a binary relation, let f be from A to B. Okay, you have 2 sets. There is a binary relation. That binary relation is a function, if it is a function, then we are going to see whether it is into function, onto, or 1 1. For that, the condition that we need to see is that f will be an into function if and only if the first condition is that the domain of this f should be equal to a, because as it is a function, definitely this condition should satisfy. And the second condition of the function, which was that first element should not repeat. Okay, these were the two conditions that we needed when we wanted to prove a binary relation to be a function. So these are the basic conditions of a binary relation to be a function. Okay, the third condition will determine the type of the function. Okay, these two conditions are included in all the definitions of the types of function. But the third condition, which will actually determine whether the given function is into, onto, or 1 1. In into function, the range of the binary relation which is given to f, that should not be equal to b. Okay, we know that the second element is taken from the set B, and we know that if you make a set of the second elements in a binary relation, then that gives us the range of the binary relation. So for the given binary relation or given function to be an into function, you need to check whether the range of that binary relation or that function is equal to b or not. If it is not equal to b, it's called into function. Okay, and in the next definition, we are going to see that it will be an onto function if the equality prevails. Okay, so over here we don't want the equality, we want the inequality. Okay, so focus on the range of f and b. If they are not equal, it's an into function. Okay, and the first two conditions are same as we did in the function, because the into function is a function, so it should satisfy the conditions of the function. Only the third condition is the thing which is added in this concept. Okay? Let me take an example. Let's see, if you have, suppose a is equal to 1 2 3 and b is equal to a b c d. Okay, and suppose that g is a binary relation that is given to us, and we want to check whether it is a function or not, and if it is a function, what is the type of function, what is its type. Okay, now for the solution, this is the example. Okay, for a solution, let us check all these conditions one by one. The first condition is that we have to check whether its domain is equal to a or not. Now if I find the domain, if I collect all the first element, we get the domain after we make a set of it. So 1 2 3, this is the domain of G, this is the set of A, both are equal, so the first condition is satisfied. Okay, for the second condition, we should check whether the first element is repeating or not. We have non-repeating first element, so non-repeating first element, so second condition is also satisfied. Okay, now moving to the third condition, which will depend. So it means that this binary relation is a function. Now to find the type, we have to observe its range. Okay, if I find the range of G, then the range of G is the set of all the second elements, which is A, B, C. Now range of G is A, B, C, while the set B is A, B, C, D. Now if you observe these two sets, then we can easily declare that range of G is not equal to B. So range of the given binary relation is not equal to B. So the third condition is also satisfied. as all the three conditions of the into function is satisfied, so our conclusion is that g is an into function. Okay, so this is all you need to check if you want to find whether the given function is into or some other type. Okay, the first condition is also satisfied, second condition is also satisfied, the third condition was the range of g should have been equal to b. So we have calculated this range and we have found that it's not equal to b. So the third condition is also satisfied because here we needed the inequality and we have the inequality over here. So it means that the given binary relation is not an into function. Now let's move to the next type, which is onto function. Onto function. Now in onto function we have three conditions. The first two conditions are same as before, and that is domain of f should be equal to the set A. Okay, and second condition is again the same, non-repeating first element. Okay, repeating first element, and the third condition is over here is that the range of the function should be equal to b. Okay, and into function what we had is that we had the inequality that the range should not be equal to b. Here we are saying that the range should be equal to b. So if the range of f is not equal to b, you are going to say that the given function is into. If it is equal to b, then it will make the given function an onto function. Okay, let me do an example. Okay, as an example, I'm going to take the set A to be equal to 1, 2, 3, and B, let us take B as A, B, C. Okay, and let us take a binary relation and check whether it is a function or not. If it's function, let us check its type, 3B and 1C. Okay, so its solution is that, first of all, let us check the first condition. Let us find the domain of G. The domain of G, as you know, will be equal to 2, 3, 1. 2, 3, 1, which we know is equal to, can be written as 1, 2, 3, and it is equal to the set A. So the first condition is satisfied. Second condition is that we should have non-repeating first element. Okay, non-repeating first element. Now if you observe this binary relation, the first element is not repeated. Okay, for every first element we have a unique value of the second element. For every x we have a unique value of y. Okay, so 2 is not repeating again, 3 is not repeated, 1 is not repeated, so it means that the second condition is satisfied. First two conditions are done. Now let us find the range of this binary relation. Now for the third condition we need to find the range. Now the range of G is the set of the second element of the binary relation, which are A, B, and C. Now if you find the range, you may see that here is B, here is range of G. We know that it is equal to B, so the third condition over here is satisfied. Okay, so what will be our conclusion is that G is an onto function. Okay, that's it. So this is how you find whether a function is onto or not. Suppose if it was not equal to b, then we would have said that it is an into function, not onto. But over here the range is equal to b, so it means that the given binary relation is an onto function. Now let us move to the next type, and that is 1, 1. Okay. For 1 1 we will need a third condition, and we will need to change its name. 1 1 function. Okay, now let f be a binary relation from A to B. F will be an I'm sorry, I didn't change this. F will be a 1 1 function. Okay, do change it in the previous definition. Here I forgot to write on2 over there. Okay, I changed it here but not here. Just change it in the previous definition. Okay, the conditions for 1 1 function is that f will be an 1 will be a 1 1 function if a 1 1 function if domain of A is equal to A, non-repeating first element, and the third, these two conditions are for the function. The third condition will be that it should have non-repeating second element also. Okay, so in 1 1 function we have, for every value of y we have a unique value of x. Okay, just as for every value of x we have a unique value of y, then the reverse should also be satisfied. Then we say that the function is 1 1. For example, let us take a set 1 2 3, and b is a, b and c. Okay, and suppose we have a binary relation 2c 3a and 1b. Okay, now let us see if it is a 1 1 function or not. The first condition is that domain of f, whether it is equal to a or not, I am going to calculate the domain of f, which is 2 3 and 1. Okay, 2 3 and 1, and in the set we know that we can easily change the order. It does not matter. Okay, it does not change the set. So this is equal to a. First condition is satisfied. Second condition is that you have non-repeating first element. As you may see, the first element is not repeating, so second condition is also satisfied. And the third condition is that you should have non-repeating second element also. Okay, so as you may see, C is not repeated again, A is not repeated, B is not repeated. For every A, for A you have a unique element of x3 over here. Okay, for C you have a unique element of x, that is 2. So second element is also not repeating, so the third condition is also satisfied, this one. Okay, as all the three conditions are satisfied, so the conclusion is that the given binary relation f is a 1 1 function. Okay, so this is how we check whether our function is 1 1 onto or into. Okay, now there is one more result, a very small one, in which we have a definition, and that is one more extra definition to be noted down. You have to note it down, is that a function which is both onto and 1 1 is called a bijective function. Okay, okay, so if you have a function which is both 1 1 and onto, which satisfies the three condition of 1 1 as well as it satisfies the three condition of onto, then if it satisfies the condition of both these types, then such type of function is called bijective function. Okay, bijective function. Okay, if it is 1 1, then 1 1 function is also called injective function. Onto function is also called surjective, and this onto plus 1 1, if it is contains the properties of both the types, then such type of function is called bijective function. If you need an example, let me give one example, a quick example. For example, if you have a 1 2 3 and b is a b c, and suppose you have a function g which is 2b 3a 1c. Okay, so over here I will do it quickly because these are the domain of G is equal to 1 2 3. Okay, it is equal to A. Second is that non-repeating first element. Okay, the first element is not repeating, so the second condition is also satisfied. Now the third condition is that the range of G, that is equal to BAC or ABC, which is equal to B if you compare it. Okay, so it means that as the range is equal to B, so it is an onto function. Now if we check one more condition, that the second element is non-repeating. Okay, is not repeating, is non-repeating. So second element is not repeating because B is used only once, A is also used only, and C. So it means that it is 1 1 function also. So it is both onto and 1 1. Therefore G is bijective. Okay, bijective function. Okay, so this completes the topic. We have done the definition of function, then we did the definition of different types of function, and this completes the concept. Now question number 6 in the exercise is of this type, and there you have to judge the function whether these are 1 1 onto or into, in the same way as I did in all these examples. Okay, these are all detailed example. Now you can, this example can easily guide you to do question number 6. Go through question number 6. If you don't understand it, then do ask me.